Hello everyone, how are you all? So I am Siddharth Marjha and today I am going to talk about the multiple and polynomial regression. Okay, so just do a quick recap like what we have did in the last lecture. So we have learned about the regression. So regression is the predicting continuous values, and we have talked about the simple linear regression. So it is nothing but one input variable and one output variable. Okay. So for example, we have seen one the straight line formula y is equal to mx plus c. So now we will discuss like multiple linear regression, which is like MLR basics. Okay. So the concept is like where more than one independent variable is used to predict the dependent variable. Okay. So its example, its equation is like B naught plus B1 x1 plus B2 x2 like Bx and x, Bn xn. Okay. So B1, B2, B3 are nothing but the coefficient, each of the features of on Y. So there is some assumption. So assumption is like the linearity between the features and target and non multi-correlationary among the predictors, like multi-collinearity among the predictors, and the error is your normally distributed. Okay, so let's understand it in the detail in the notepad. So let me open the notepad first. So here the topic is your multiple what happening multiple linear regression. Okay, so the concept is like when more than one more than one independent variable is used to predict the dependent variable. Okay, so the general equation for this is y is equal to b naught plus b1 x1 plus b2 x2 and so on bn xn. Okay, so here the b1 b2 dot bn is nothing but the coefficient that effects on each features on y features on y. Okay, so just take an example. Suppose you are predicting the house based on the square like size and number of bathrooms and location score and age of house. Okay, so here the assumption is explained clearly like the linearity, non-multilinearity, and homosceding, homoscedicity, and independence and normality of reduce. Okay, so let's understand this. So assumption. So the assumption. So first one is your linearity. So linearity is nothing but the relationship between independent and dependent variable is linear. Okay, so next one is multi no multi collinearity. So what it is basically in this independent variable independent variable should not be what? High correlated. High correlated. Okay. So the next one is your, let me write it down. Homoscedasticity. So what it means, it cannot, it is a constant that varies, that constant variance of recitals. Okay. So next one, the fourth one, which is independence. So this is nothing but the observation are independent. Observation, what we are doing are independent. Okay, and the last one is like normality. Normality of recitals. So what it means? So it means like errors should follow normal distribution. Okay, normal distribution. So now we will take on the head-on, hands-on example for the house prediction system. So let me open the Jupyter notebook first for that. Okay. So just hold a second. It takes time to open. So just hold a second, guys. Yeah. So it is open. So now I am going to create one new, or what it is, a notebook. Okay. So select Python 3, okay, as your kernel. Okay. So now I am going to write about the code. Okay. So first of all, we will import the library. So we will import the pandas and your linear regression model. Okay. So we will import pandas as PD, and we will import your sorry, from sklearn dot linear model import linear regression. Okay, linear regression, just run this. So it will import your library. So next we will give our data sets. So let me copy and paste our data set because it is too much. So yes, this is the data set I have given. So the size I have given, and the number of bedrooms, and the age of the house, and price I have given. So the next one, which I am going to write, which is independent and which is dependent variable. Okay, so I will write like x is equal to data and your size. So here you will write like this, your features, what it is. So your size, and you will write like the bedrooms. So bedrooms and next you will write like your feature which is age, and the next you will write like your price. Okay, so price. So this is your independent variable, independent, and next we will give to the dependent variable which is price. So y is equal to data, and we will give the price. Price is nothing but the dependent variable. Oh, sorry, by mistake I have written price in the independent variable. It is a dependent. So let me remove it from here. So this is your independent, and this is the dependent variable. Dependent variable. Okay, so let run this. So just hold a second. So it is still executing now. So there is one error. What key error? Bedroom. Okay, so let's see where is the bedroom is there. So, oh, the spelling mistake is there. Bedrooms. So now we will write like uh, so we have seen like independent and dependent variable. So now we are going to train this. Okay. So for training the model, I have to write like model is equal to, and which model I am going to apply? Linear regression. So linear regression. Okay. And the next you have to write like model dot fit, and x comma y. Okay. So here you are training your model. So now we'll check the coefficient. Okay. So we will write like print. Okay, and intercept uh, intercept, and give the model dot intercept. Okay, so it will give me the value of the intercept, and we have to print like the coefficient. So we will write like print, and we will write the coefficients. So it will be your, you have to write like model dot model dot coef. Okay, so let's run this. So it will give the interpret value and the coefficient. Okay, so now the next what we will do. So here the size coefficient like increase in a price per extra square feet, and your bedroom coefficient is your efficient of adding a bedroom, and age coefficient how age decreases value. Okay, so now we will do the prediction. So for that we have to write like test, sorry, here test underscore house is equal to, we will give the input 250 comma 3 comma 15. Okay, so for this, and I will write like predict price is equal to model dot predict, and you have to give the test house. Okay, so now we will print it. So print predicted price is okay, and we will give the print price and at the 0. Okay, so just run this. So there is one error in the second line. Okay, so model dot predict. Sorry, here it will be like model dot predict. Now run this. Yeah. So see the predicted price it give us. So it is like 53, 5,35,386. Okay. So if we are searching for the size which is 2,500 square feet, and your bedroom should be like 3 and the age of 15, so the output will be like predicted price of that room should be like 5,35,386. Okay, so now we will understand the polynomial regression. So let's go to the notepad to understand it. So now we will see about the polynomial regression. So the third one is your polynomial regression. Okay, so what it is, the concept is like your linear regression only fits a straight line, and the second concept is like but real world often shows like curved or nonlinear trends, curved and nonlinear trends. Okay, so the next we will understand like polynomial regression. So polynomial regression. So the polynomial regression is nothing but your adds adds polynomial terms of x like x square, x cube, and all to model nonlinear relationship. Okay, so for example, the equation of the polynomial regression, which is y is equal to b naught plus b1x plus b2 x square plus b3 x cube and so on, bn x to the power n. So just write this formula. This is for the polynomial regression. Okay, so like you have to predict, for example, you have to predict salary versus experience. So what you can do? So at first, salary increase quickly with experience, quickly with experience, and the next one is like later growth slow down, which is non-linear. So this is like non-linear. Okay. So now we will do the hands-on like what it is demonstration of this multilinear your polynomial regression. So let me go to the VS Code and we'll do the sorry, not in the VS Code, in the Jupyter book. So let me go to the Jupyter book for its practical demonstration. So just a second. Uh, yeah, so it was already open. So here I will come and this window I will close and I am going to create one new notebook. Okay, so let's wait. It's opening. So in this, we have to import some libraries first. Okay. So what library we will import? Just tell me. Till now, I have shown you so much of practical demonstration of each stuff. So I think you can able to import the library now. Okay. So the library, first one which we will import like import numpy as np, import numpy as np. And next one you will import like matplotlib as plt. So import matplotlib dot pyplot as plt. And the next one which you will import like sklearn pre-processing. You have to you have to import like polynomial features. Okay. So from sklearn dot pre-processing import polynomial polynomial features. Okay. So the next one which we will import like linear model for the linear regression. Okay. So from sklearn dot linear model import what you will do linear regression. Okay. So just run this. So it will import the all the libraries. So yeah, it imported all the libraries. So now I'm going to paste the data here. Okay. So now I'm pasting the data here. So yeah, this is the data is given. So let's run this. So we have given the data set. So now we'll apply the linear versus polynomial fit. Okay. So in the linear fit, we will do like linear underscore fit, linear underscore regression is equal to linear regression. Okay. And for linear regression dot fit, and we'll fit it on the x comma y. Okay. So this is nothing but your linear regression. Sorry, this is your linear regression. So just run this. So it will fit the model. Oh, there is some error. Y. A linear regression fit missing one required potential argument, which is y. Okay, fit x comma y. Where it is? Uh, Let me see what the problem. So, yeah, the problem I got it like here I have written the small x, I think. No, that was okay, but yeah, let me run this first. Yeah, so the error was nothing. So just we have like import we have just do the linear regression now. So now we will do like your uh, what it is, what's the next one? Polynomial regression. Okay. So for the polynomial regression, you have to write like poly is equal to polynomial regression, polynomial features, and you have to give the degree. Okay. So degree is equal to 3. Okay. And you have, because it is polynomial, so you have to give the value of x cube. Okay, x to the power n. You have to give the value for the n. N is nothing but the degree. Okay. So next you have to write like x underscore poly is equal to now you are going to fit it. Okay. So poly dot fit transform and on x value you are fitting it. Now you will do like the polynomial regression. So poly underscore regression is equal to linear regression, and you have to poly like poly regression dot fit, and on which you are going to fit this. So x underscore poly comma y value. Okay. So let me do the capital X here and here also. So just run this. So here see it does the polynomial regression for the degree 3. Okay. So now we will do the visualization. So for the visualization, I have to draw the graph. Okay. So some scatter plot I am going to do. So let's see how we are doing. So the first of all, you have to write like plot dot scatter, and then you have to give the value like x comma y comma color is equal to blue comma label is equal to you can see the actual data. Okay, and now you have to do it like a linear fit. So for that you will write like plot underscore plot sorry, plt dot plot, and here you have to give the value like x comma uh, linear regression comma linear regression dot predict. You have to do linear regression dot predict, and you have to predict the x value, and the color of this you can give like color is equal to red, and your label is equal to what it is, linear regression. Okay. So now we will do the polynomial fit. So for that we have to write like x underscore grid is equal to np dot linspace. Okay, and here you have to give the value. So like 1 comma 8 comma 100, and then you have to reshape it. So reshape it on what scale? So -1 to 1, -1 comma 1. You are going to reshape it. So now you have to like plot it. So you are writing like a plot plt dot plot, and here you are writing like x underscore grid, comma, poly regression dot predict, poly regression dot predict, and you have to predict the transform of x grid. So you are writing like poly dot transform, and in which, so on the x grid, x underscore grid, and here we will give like the color is equal to green, color is equal to green, and the value of label is equal to, you will give like what it is, polynomial regression, polynomial regression. Okay, so now just give the x level and y level. So plot dot x level, and here you have to give like the experience level, and in the plot dot y label, you have to give like the salary, and you have to write like plot dot legend, and you have to like call the show function, so plot dot show. So just run this. See, the polynomial curve is came, but there is some attribute error. Like linear regression is no attribute like predict. Oh, a spelling mistake. Predict. In which line? Linear regression. So where I have written the linear regression dot predict. Here predict. Now run this. So see, the actual polynomial curve is given, and the actual straight line. The red one is your linear regression, and the blue point is your actual data, and the polynomial regression is your green line. So I hope this is you are easily able to like analyze it. So now we will understand. So till now we have understand the polynomial and the linear regression, and the multilinear regression also we have seen. So now it's time for the next topic, which is base variance trade-off. So let me, you are writing now. So just write this, okay? Or just write it. I am giving you the 10-second time. Okay, I am still waiting. Just complete it fast. Okay, so I hope you have written this. So this you will get the output. So now I will cover the base variance trade-off. Okay, so the next topic is base variance trade-off. Okay, so in this we will understand the linear regression. So it is high bias, high bias, too simple and many underfit. So too simple and it may underfit. Okay, and the next one, which is like polynomial regression. So in the polynomial regression, there is like high degree a high degree. So basically, this is cause low variance, or sorry, low bias, but high variance. Okay, this is called is overfit. Okay, and the next one, the last one is balance. So balance, choose optimal polynomial degree. So I hope I am clear. So in this video, we have learned about the multiple linear regression, like more features and better predictions, and learn about the polynomial regression, which captures nonlinear pattern. And we have also saw the partial coding demo. So just a second. So we have saw the partial demo coding. So next we have introduced the bias variance trade-off. So in the next lecture, we will complete the model evaluation matrix, which is RMSE or MAE or your R square and adjusted R square. And we will compare the performance of the simple, multiple and polynomial regression and case study with real life data set. Okay. So this is about the today's lecture, and I hope you guys has understand the basic and fundamentals of the polynomial regression and multi regression. So see you in the next lecture. Tab tak ke liye keep learning and keep exploring. Bye bye.